Good morning.
Good morning.
Okay, well, let's see who's here today. All right, so Joseph City, everybody's there? Holbrook, everybody's there? How about Winslow? Everybody there? Looks like we might be missing.
Oh, we're missing Brooke, Andrew, and Dominic.
So Brooke and Dominic
And Andrew.
and Andrew. Okay. All right. So, first of all, I want to tell you that, so I ended up going and looking over the midterms again. And so basically what I've decided to do is do a 10-point curve. I might have said 8 or something. Did I say 8 before? Okay, it's going to be 10 because there was an additional problem that, anyway, I wanted to give everybody credit for. So whatever your score was, I'm going to go back in and manually change the overall score by adding 10 percentage points to it. And then it will recalculate your grade. Okay? The other thing is that a couple of you might have asked me to retake or for me to open up a quiz in like 8.1 or 8.2, and I might have said no because it was before the midterm. Anyway, but then kind of on second reflection yesterday afternoon, I thought, wait a second, I was going to keep all those quizzes open until we finish chapter 8, which was today. So, so what I'm going to do is I'm going to go back and reopen all of chapter 8 quizzes this afternoon, and they'll be open for another week. Okay? So if I told you I wasn't going to reopen a quiz for you, I rethought that. Okay? So they'll be open. So if you missed a quiz from 8.1 or 8.2 or 8.3, even though it was before the midterm, because I said I was going to keep the quizzes open, I'm going to do that. So you can be looking for those quizzes to open up. Okay?
Thank you, Mr. Strong.
Thank
You're
you.
welcome. You're welcome. I just want to be fair, okay? That's very important to me. All right, any other questions or concerns? And that actually came up because a student asked me. They said, well, about that. Like, I thought you were going to keep them open until the test. So it really is helpful if you talk to me and communicate your concerns with me. So anything else? Okay, so oh, go ahead.
You have to leave for baseball at 8:30 or 8:30, 11:30.
Okay, all right. So well, I'm glad. So you heard about the chapter 8 quizzes. So we have. I just wanted to go over. There was one last question on 8.6 that I want to go through, and then we'll be done with 8.6 and chapter 8, and then we are going to go on to 9.1. So if you don't have the guided notes, I sent those out about a half hour ago. So maybe you can see if you can get those, or do you guys have them? The 9.1 notes? So you might see if you can get those printed off while we're going over that last problem. Okay? All right, so thanks for the heads up on that. So just watch for the video, and hopefully we'll get back into a flow where I'm doing the videos and so on. So we'll be good to go with that. All right, any other questions or concerns? All right, well, let's go back to that last problem. I thought we could get through it, but it's an important problem. So I want to make sure, and that's where our well, it was on 8.5 actually. Wait, let's see, was that? I'm a little confused. Oh, it was about whether vectors were orthogonal, parallel, or neither. Okay, so that's where we are. So let's go to that. Okay. Okay, so we said orthogonal was just kind of a fancy way of saying perpendicular, but maybe in 3 dimensions. And that to determine if vectors are orthogonal, you look at their dot product. And if the dot product is 0, then they are orthogonal. Okay? Now, to figure out if vectors are parallel, if one is a multiple of the other. So like if you take a vector and multiply it through by 10 or 5 or 3, then those are going to be parallel. Okay? So the question that you will have is, you'll be given 2 vectors and say, are these vectors parallel, orthogonal, or neither? All right? So the first thing you do is you say, well, what's their dot product? And if you remember yesterday, the dot product, we said 2 times negative 50 is negative 100. 5 times 20 is 100. So that dot product is 0. So we're done. The answer is orthogonal. So if their dot product is 0, it's orthogonal. Okay? Now, let's say we have these 2 vectors. Are they orthogonal, parallel, or neither? All right? We do the dot product and we get negative 40 plus negative 250. That's not going to be 100. Okay? So they're not orthogonal. All right, but then we notice that if we take this first vector and multiply it by negative 10, we get that second vector. So what that means is that they're parallel. So if one is a multiple of the other, then they're parallel. Now, if neither of those situations are going on, then the answer is neither. Okay? So if you had, just some, so like here, see, if you were to multiply, well, no, that's not what I want. No. Okay, so this is the one that's on your sheet, I think. Are these vectors orthogonal, parallel, or neither? All right. So first you do the dot product. Okay, so if you haven't done this yet, do the dot product of those 2. Okay. Brooke's not here, right? Okay, so Ellie, what's the dot product of these two vectors?
0.
0. So if the dot product is 0, then the answer is
Orthogonal.
orthogonal. Okay? So if the dot product's not 0, and they're not a multiple, one's not a multiple of the other, then you just put neither. Okay? All right? Any questions on that? Okay, so that's it for 8.6. So like I said, I will be posting the quiz for that, as well as and open up all the quizzes for chapter 8. So they'll all be, if they've closed, they'll be reopened for another week. Okay, and then the chapter test. So hopefully you haven't put everything off, because you do have that chapter 8 test. All right, now, okay. So now let's go to chapter 9. Okay, so chapter 9, before I start on this, this is on what's called conic sections. And before I start on this, I have to do a little bit of a rant. Okay? So here's the deal, is that you guys have all heard of Common Core, right? You've had to endure some of those AZ merit tests with the Common Core. Well, when they came out with the Common Core math standards, and through high school math, they decided to drop conic sections. Now, this is a college class, so we've got it in here, and you need it for not only trig, but you also need it for calculus. But it used to be, when we came to this chapter, it was like the easiest thing in the world, because the students had already had it. Okay? Now, I'll bet you some of you have never had it. Are there some of you that have never studied conic sections before? Raise your hand if you've never studied before. Okay? See, to me, that's a shame. And I teach it as if you've never had it. So I'm not assuming you've had it. But it's a shame, because guess what? Conic sections are still on the ACT. So if you've taken the ACT, or if you're going to, or whatever, this will help you in a lot of ways. But it's just frustrating to me that they decided to drop it, and then students have to take the ACT with conic sections on there. And so, to me, at what point did we stop preparing kids to take a college entrance exam? But anyway, so when I was the department head at Holbrook High School, I would ask all my teachers to just keep on teaching it. Didn't matter if it was on the AZ merit or not. The test that actually means more to you, and we better plug the ears of any administrators that walk by, but the tests that mean more to you are like the ACT. It's not the AZ merit. But anyway, all right. Well, let's go ahead. So the conic section. So this material is on the ACT, on the SAT, and so we're gonna, in this first section, it says is the ellipse. But before we do the ellipse, I'm actually going to give you a little bit of an overview into all of it. Okay? All right, so we'll do an overview, and then we'll talk about standard form and some applications. All right, so conic sections have been studied since before the time of Christ, okay? 600 to 300 BC. Early Greeks, and basically it gets its name from the intersection of two cones. And so that's why they're called conic sections, okay? So here's the two cones. All right, so a conic section is the intersection of a plane with this double napped cones is what they're called. So if the plane goes parallel to the base of the cones, then it forms a circle. If the plane is at an angle to the base, then it forms an ellipse. And if it intersects goes through one of the bases, then it forms a parabola. And if the plane goes through both bases, it forms a hyperbola. So these are the four conic sections: circle, ellipse, parabola, and hyperbola.
Mr. Strong,
Yes.
Brooke, Andrew, and Dominic are here. They had another.
Brooke and who? Dominic?
And Andrew.
Oh, wonderful. Awesome, thank you. Okay, so those are the four conics. Okay, actually, let's go back. Let's do this. Okay, so if the plane doesn't intersect, if it goes through the vertex, then what you end up with is a degenerate cone. And so the degenerate conics are a point, line, or an intersecting lines. Okay, the degenerate conics. So that's the next blank. If it passes through the vertex, you get a degenerate conic, like a point, line, or intersecting lines. And so, we've studied points and lines before, but now we're going to focus on the regular conics, like the four that were listed. Okay, so now if we have an equation, I actually here's the entire equation, and that's same as what's on your sheet. But really, when we look at this and we can identify which of the conics just based on the A and the C. So I'm going to cover up this whole big equation because we don't really need it. The focus is just going to be the A and the C. So the coefficient of the square term and the coefficient of x squared and y squared. So the two squared terms. Okay. So if we look at the equation and A is equal to C, if those numbers are identical in this front of the square terms, then that gives you a circle. And then if A times C is 0, then you get a parabola. So what that means for them to multiply together to get 0, that means one of them is 0. So if you only have one square term, then it's going to be a parabola. All right. Now, if A times C is a positive number, so either they're both positive or both negative, then you get an ellipse. And if A times C is negative, so one's positive and one's negative, then you get a hyperbola. All right? So that's just kind of a little bit of an overview. And then what we're going to do over the first 4 sections of this chapter is focus on each one of those. Okay, now, one of the important things that all of the conics will have in common is certain terminology, okay? So, like here, we have points that help us draw an ellipse, a parabola, or so on. And so, like, we'll talk about a focus or foci. And we'll also have words like directrix that will be involved. Now, you don't have to write any of this down now. I'm just trying to give you an overall feeling for it, and then we'll. But one of the differences that we'll discuss is that, like, a circle is the set of all points that are same distance from the center. The ellipse is the set of all points that are the sum of 2 distances. The parabola is the set of all points that's the difference, where the distance between the foci and the directrix are the same. Those distances are the same. And then the hyperbola is the set of all points where the difference between 2 distances are the same. So that's kind of unique in the way that they're all defined in terms of distances. Okay? All right. Now, we're going to we actually studied circles in Math 152. And so we're going to, for the most part, de-emphasize that. We're not going to really go through that again. But the other 3, we are going to spend quite a bit of time on each one, at least one class period. All right, so starting with an ellipse. So ellipses became more and more important with the advent of astronomy. Is that, the early astronomers thought that all of the orbits of the planets were perfectly circular. Okay? But it turned out that they're not. They're actually elliptical. And so I think this Neptune is actually the one that kind of has a crazier orbit that's way elliptical, that doesn't quite line up with the other planets. Okay. Now, so with the declassification of Pluto as a planet, we're down to 8 planets, right? But have any of you heard of Stanford University's discovery of a 9th planet? Have any of you heard anything about that or read anything about it? Well, it doesn't have a name yet. They're just calling it a 9th planet because it's only been discovered mathematically. And so it's kind of like, imagine if you could be invisible and you were passing through the school halls and you were, running through the halls and pushing people and everything. I mean, you could kind of tell that there's a person running through the halls just because of the effect on other people, even though if they were invisible. Well, it's like that this 9th planet, they haven't actually seen it yet, but they know it exists because of how it affects how its gravitation has affected the orbit of other things. And so it's kind of interesting because they theorize that the reason why that this 9th planet has not been visible is because we haven't been looking for it, because it's not in the plane of the other planets. Now, I'm using a geometry term there. What do I mean by it's not in the plane of the other planets?
It's not on like the same axis or surface as other planets.
Yeah, so these are all, I mean, you kind of imagine a flat surface would hit all of these, even crazy Neptune. Okay, but this ninth planet that are actually so if my fingers represent all these planets orbiting the sun, right, but they're all kind of lumped together. Well, they theorize this ninth planet is coming like this, so its orbit is almost perpendicular, and so how long does it take for Earth to orbit the sun?
365 days.
Yeah, 1 year, 365 days. So the theory in Mercury's like 88 days, and some of these other ones are 1,000 days. They think that this ninth planet actually its orbit is more like 10,000 years. Okay, so which is kind of fascinating to me. So anyway. So they don't, until they see it, they really don't know when it's going to come close enough for us to see it. Okay. Anyway. Okay. An ellipse. So an ellipse is the set of all points x, y in a plane, the sum of whose distances from two distinct fixed points, the foci, is constant. So these two distances are the same. So as you go around the ellipse, if you were to measure the distance between the two foci, you'd always get the same number when you added the two distances together. All right. Now we have the center of an ellipse, and then we have the major axis. That's kind of the long side of it, and then the long distance, and then we have a minor axis. The two ends of the major axis are called vertexes or vertices. Now, when we get good, we can just look at the equation sometimes, and tell what all of these are. Okay, now, let's see. Now, let's go this one. Okay, here we go. The standard form of the equation of an ellipse with center HK and major and minor axes of 2A and 2B respectively are, okay, so if the major axis is horizontal, then you get x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, the way the book does it is that they come up with a separate equation if the major axis is vertical. And they do the b squared over here and the a squared over here. The way that I do it in my brain is I just say, whichever of these numbers is bigger, is going to determine the orientation of the ellipse. So if the bigger number is under the x, if this is bigger than this number, then it will be a horizontal ellipse. If the bigger number is under the y, then it will be a vertical ellipse. Okay? So the first paragraph in that second column, you might underline the word horizontal, and the second one underline the word vertical, because otherwise those two are about the same. So in both cases, the foci lie on the major axis, c units from the center with, and then this is another important formula, c squared equals a squared minus b squared. So the c is the distance to the foci. So this formula helps us find the foci of the ellipse. Kind of like, so it's kind of equivalent to the center of the circle. All right. Now, this kind of looks like the Pythagorean theorem, but the sign is opposite here. So you got to be careful with that. Now, if the center is at the origin, 0, 0, then that means h is 0 and k is 0. So when you put in zeros into these two formulas, then it simplifies down to these two formulas. Okay? So once again, I just kind of memorized this first one and then just say, look, if this number here is bigger, then it's horizontal. If the number underneath the y is bigger, then it's vertical. Okay. All right, so let's say I had a problem like this. Okay. So the center here, see, there's no numbers with the x squared and the y squared. So that means the center of this ellipse is 0, 0. So usually you start there. Okay. Then the number underneath the x squared determines the horizontal. So how far you go to the left and to the right. And so it's the square root of this number. So the square root of 16 is 4. So you would go from the center. Let's see. I guess we've got to go to another slide. So from the center, we would go left and right 4. And then in the y direction, up and down, we go the square root of this number, which is 3. Okay? So really, that's all we need to graph this. Let's see. I'm still not seeing the graph here. Okay, so we go, the center's at 0, 0. Then in the x direction, we go left and right 4. In the y direction, we go up and down 3. So then to complete the ellipse, you just connect those 4 dots in an elliptical fashion, and you've got the graph. Okay? Now, the other thing that you want to be able to do is find these 2 points, the foci. And so the equation that we're going to use for that is the c squared equals a squared minus b squared. So the c is the distance to the foci. So you plug in the a squared and the b squared right from the equation. And so you'll subtract and get 7. So then you take the square root and you get plus or minus the square root of 7. So that c is the distance from the center to the foci. So plus or minus the square root of 7. So then from the center point, 0, 0, okay, then we measure over square root of 7 and negative square root of 7. So that gives us our 2 foci, plus or minus the square root of 7, comma 0. All right? So see if you can do practice 1A. So I don't ask you to graph it, just find the center and the foci. All right, so Cameron, what's the center of this ellipse?
$21.
No, that's going to be the C. That's the next question. Okay? The C squared is going to be 21. The center is just, see, is the H and the K, the number with the X squared and the Y squared. But since there's no numbers up here, then it's 0, 0. Okay? I know I kind of taught that last with the equations, but it's actually easier, so I'm starting with that. So the center's at 0, 0. Okay, so then when you do the 25 minus 4 and get 21, okay, that's C squared. Okay, so then the C is plus or minus the square root of 21. Okay, now sometimes the foci, depending on the orientation of your ellipse, if you have a vertical ellipse, then you would go up and down the square root of 21. If you have a horizontal ellipse, you'll go left and right. Okay? Since the number under the X, and the X determines left and right, since this number is bigger, then it's going to be a horizontal ellipse. And so plus or minus the square root of 21 would be your foci along the x-axis. So you would count over left and right the square root of 21. So that's like 4 point something. So you just estimate. Okay. All right. So any questions on the C or the center? Let's write that down too. The center is at the point 0, 0. Okay. All right. So now try. I guess I'll do one here that. So if if you have numbers on here with the x and the y squared, see it's the h and the k that's the center of the ellipse. Okay. So if you have x minus 1, y minus 1 inside the parentheses, then the center of the ellipse would be 1, 1. Okay? And then in the x direction, you would count over 5 in each direction. In the y direction, you go up and down 4, the square root of these numbers. Okay? Now, to find the c on this one, you still use these. So it's 25, c squared would be 25 minus 16, which is 9. And so then c would be plus or minus 3. So once again, from the center point, you would count over 3 in each direction. So 1, 2, 3. So if I add 3 to the x value of that, I get the 0.41. If I subtract 3, I get negative 2, 1. Those would be the foci. Okay? But you have to find the center first. All right, so go ahead and try practice 1B. All right. So Junior, what do you have for the center?
-2, 1.
Okay, it's in the formula, it's x minus h and y minus k. So you actually have to take the opposite of them. So it's going to be +2, +2, -1 will be the center. So you take the opposite. So it's kind of like, I don't know if you remember when we did circles last semester and we did the h and the k for the center of the circle, but we had to do the same thing. Okay, so you take the opposite of the numbers inside. So it's +2, -1 is going to be the center. Okay. All right, and then what's c squared? To find the foci, what's c or c squared? Anybody?
Plus or minus square root 7i.
That's right. Plus or minus the square root of 7. Okay, now, so now what we have to do, since this number is bigger, then it's a vertical ellipse. Okay? So then to get the foci, we go up and down the square root of 7. Okay? So the actual points, see, we're not going to touch the 2. These are still have an x value of 2, but the y value here is going to be -1 plus the square root of 7. And then this one is going to be -1 minus the square root of 7. Okay? And so you can kind of combine that and say the foci are 2. The x value is 2. The y value is -1 plus or minus the square root of 7. What you got for C. Okay? Any questions on that? Okay, so this next example is where we're trying to find the equation of the standard form of the equation of the ellipse. Okay, and so this time, instead of giving us the equation and then we find the foci or something else, we're given information and we have to come up with the equation. So the thing that helps me on these is to actually put on a graph the information that I have. Okay, so like here it says, find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1, and a major axis of length 6. Okay? So what I will do is graph the foci. And so here's 4, 1, and 0, 1 are the foci. And now the major axis is of length 6, so that means it's got to be the horizontal axis because these foci are on a horizontal line. Okay? Now, how did I get this center? How did I know that 2, 1 is the center of this ellipse? How would I know that? It's not in the problem. How can I get it from the picture? Go ahead.
It's the center of the 2 foci.
Yeah, so it's got to be exactly in the middle. Okay? So you find the midpoint. The midpoint of 0, 1, and 4, 1, well, halfway between 0 and 4 is 2. So it's 2, 1. So then that means that my equation is x minus 2 squared plus y minus 1 squared, because that would give me a center of 2, 1. So now all I need to, and equals 1. It's always equal to 1. So now what I need to do is find the numbers underneath. Well, we are told that we have a major axis of length 6. So this axis right here, from this vertex to this one, is of length 6. So that means I go 3 in each direction. So if I go 3 in each direction, then what number goes underneath the x here?
9.
Beautiful, beautiful. So it's 9. Because the square root of this is 3, and we go 3 in each direction. All right, now, the hardest thing in this problem is to figure out what goes under the y. And the way we do that is using the equation for the foci, because I already have it. So I'm going to use the fact that c squared equals a squared minus b squared. So if c squared equals a squared minus b squared, I know that c, I went to the left and to the right 2 from the center to the foci. So I get 2 squared equals a squared minus b squared. So 4, 2 squared is equal to 9 minus b squared. And then if I solve that for b, actually I don't have to solve it for b. I want to solve it for b squared, because b squared is the number that goes there. So I don't have to take the square root. I can just say 9 minus 4 is b squared, and so 5 is what goes there. I don't have to figure out that b is the square root of 5, because b squared is what goes there in the formula. Okay? So the real, to try to, be a detective and put together the clues to come out with the standard equation here, to me it really helps to graph what you have so that you can see the relationships, and like the center has to go in the middle and that kind of stuff. Okay? All right, so see if you can do practice 2A. All right, so Tiana, let me know when you figure out the center of this ellipse.
1, 1.
1, how about 1, 2? Okay, because they both have a y value of 2, so it's going to be 1, 2. So kind of the way I do it is I graph those two foci, negative 2, 2, and 4, 2, and then I figure out, okay, so the number in between the center has got to be 1, 2. All right, so then from that, basically I get that. I get that part of the equation. Okay, and actually I do know it's equal to 1. All right, Taylor. What number is going to go underneath the x here? What? I didn't hear the answer. I'm sorry.
16.
No, the major axis is of length 10. So that means from the center point, you would go left and right 5. So 5 squared would go under there, and so that's 25. Okay. All right, now the C is 1, 2, 3. So C squared is 9. So to figure out the number that goes here, we've got to use C squared is equal to A squared minus B squared. So if the distance here, 1, 2, 3, so C squared is going to be 9. And A squared we said was 25. So what's B squared going to be?
16.
Okay. And so then that, whoops, I didn't put it in there. So then once we find the 16, then that's what goes underneath the Y. Okay. So you find the center first, and then either A squared or B squared, and go from there. Okay. All right, so oops. I know we're about out of time. Okay, so the first step to sketching an ellipse is to put it in standard form. So if it's already in standard form, you're golden. But if it's not, then you're going to have to work a little bit more on those. Okay. All right. So again, well, let's just pick it up from there. So why don't you try to graph this, and then we'll go over it on Monday. Okay. So we'll just stop right there and review. So again, look for the quizzes, look for the tests, look to have a great weekend. And if you're in Holbrook, go see the Addams Family. Ellie's in it, and it's free. Okay, and are you singing a solo in that, Ellie?
Yeah.
Nice. All right, so come support Ellie. Anything else going on we ought to know about? All right.
Good luck, Allie.
Good luck, Ellie.
Thanks.
You'll do great. I'm going to come see it Monday night. It's on Friday, Saturday, and then Monday, right? Okay. All right. Well, you guys have a great weekend. We'll see you.